Okay, so the other module I wanted to look at was just the math module, and I'm not going to do lots and lots and lots with it, hardly anything really, just in that I'm going to show you that if you go to the, oops, that's random, here we go, math. So it's got all kinds of functions, some of which you might recognize, some you might not, and you'd have to read about them. But like it's got a factorial function, it's got a floor, which would be like truncate. It's got a mod, so the same as x% y, that operator, and what is this? This is an exponent. So this says return the mantissa and exponent of x in a pair like this. F sum. Now this is kind of important. So the regular Python has the sum command, but the f sum is much better for floating point numbers. Okay, so sum for integers, sum would work just fine, but for floating point numbers, the f sum is probably better. That's a math thing. Greatest common denominator is close to, right? Is infinite. So it's got some of these things. Least common multiple. Here's a mod. Return the fractional and integer parts of x. Interesting. Okay. Next after. That's kind of interesting. Permutations. So you can do permutations, and this is so this is return the number of ways to choose k items from n. Now this is important without repetition and with order. And with order. Okay, so that's permutations. Back here I think was combinations. Yeah, combinations. So without order, but they're both without repetition. So permutations, combinations. Some sort of product thing, I think, for maybe a iterable list of elements. Remainder, trunk, ULP, whatever that, unit in the last place. Then it goes into power and logarithmic, so exponential function. There's the power, so this would be the same as the double stars in the regular Python. But use power. There's a square root function. Trig functions. Here's a distance function and a hypotenuse function. So distance returns the Euclidean distance between 2 points P and Q, each given a sequence of coordinates. The 2 points must have the same dimension, and then there's a hypotenuse, which just if you give it a single set of coordinates, x and y, it does the hypotenuse or the length from 0 to 0. So distance is different than hypotenuse in that I can give it any 2 points. And then there's sine and tangent. We can convert between degrees and radians, hyperbolic functions, some special functions, ERF, that's the error function, gamma function, constants. You can do pi, e, tau, which is just 2 pi. You can indeed talk about infinity and not a number. And that's all of it. So there's a lot there, a lot of different possibilities, and you can just look at them and use them if you feel you need it. But what we're going to do, we're just going to look at a couple things. So actually we'll look at the hypotenuse first. So suppose I say import math as m, and I give a point here, a pair of 3, 4. Now if I want to use hypotenuse, I have to actually give the x and the y, so I had to use getting these things element-wise, the 0 and 3, whereas on the other hand, I think if I do something like origin, I don't know, maybe call that an O, it looks like a 0, so that's bad, but we'll do it anyway. Oops. Try that again. There we go. So let's try printing the distance. Print m dot dist, and it looks like we should be able to give it O and P. So it looks like we can do it that way. Let's try it. Oh, okay, what's this say? Oh, what was that name of that? Let's try that again. Dist. New in version 3.8. Oh, so again, I have not looked at the version yet. So I could try that right now. New terminal. Let me try Python. I think it's version 3.6. Yeah, so there's the problem. So I'm only in 3.6. I don't know what you all might be in, because most of you have Windows or Macs. So it may work or it may not, but that's I'm in 3.6, and this was new in 3.8, so that explains a lot. Now I could look at trying to upgrade, but it's not worth it. So given that anyway, I was going to have you do a homework where you create this distance function here using the hypotenuse function. So how about that? So that kind of, for me, that works out perfectly. So I couldn't do this, but yeah, what I'd like you to do, and I'll put it in the homework, is create a distance function, and you would give it 2 points like this, any 2 points, and it would find the Euclidean distance between them, but using this hypotenuse function that does 0, the length from 3, 4 to 0. And I'll let you think about that, is how to do it. So that's the hypotenuse function. And then here's something much more in depth that I did for you, sort of. I'm going to ask you to add to this and then maybe change it a bit. So I import math as m, I import random as rn, so I'm going to use some random numbers. I'm going to create a uniform distribution from 0 to 10, and actually those should probably be square braces because I really wanted to include 0 and 10, so I'm going to change that right now. Okay, so from 0 to 10, the distribution, the mean would be the 10 over 2, or b minus a over 2, and the standard deviation is b minus a, so 10, over the square root of 12. And see, so here I'm using the math square root of 12, and here I use a formatted output, so mu and s for those, so we know what we're heading for. Then down here in this loop, what I'm doing is I'm going to take a sample size of 10 from a uniform 0-10 distribution. So here's the uniform 0-10 continuous using random, but I'm going to put it into make 10 of these. So here's a list, an empty list, and I'm going to append each time. I'm going to append this, And then to get a sample standard deviation, I need, well, it's easiest if I find the squares of those numbers as well. So here I'm using power and power of 2 on those. And then to find mu, I need to sum up these numbers, but notice I'm using the math f-sum because these are real numbers, divided by n. And then the standard deviation for the sample, here it's not that complicated a formula, but here it is, and I'll probably put it in the homework as to exactly what that is. And then I print out for a sample of 10, I get mu for this and this, and the standard deviation. But I do it 5 times, and then I do the same thing over again for a sample of 100, and I just kind of update these to say L of 100, L100S for those, and I just change those everywhere. Some things didn't have to change, it's still a uniform 0, 10. This formula doesn't change because I made n equal 100, and I used n in the formula. And then I get a new output, and I do that 5 times to look at the difference. And if you run that, what you see is the mean should be 5, and the standard deviation should be 2.887. When I do a sample of 10, look at that, I even get a mu of like 1.9 or about 2. So these really vary quite a bit, but as you look at these, they're all much, much closer to 5 on the whole than these are. And the standard deviations are much, much closer to the, in general, to the 2.887. And what I'm going to ask you to do in homework is, copy one of these loops here and do 1,000 and compare it to these other ones here. And then I'm going to ask you to try it with a different distribution, I think, and I'll have to give you the formula for the that actual distribution. Well, or actually I'll probably have you do a normal distribution, which you'll actually just define the mean and the standard deviation for it. Okay, so that's really all I have though on the math, because it's lots of your math functions. It's so whatever you might need to do with math, and so that we'll call that done for this section.